Okay, Advanced Math Trig, Mod 7. We are on our second day of ellipses. If you remember back to last Thursday, by the way, I hope you had a great Easter weekend. We did circles on Thursday, and now we're on our second conic section. It's called ellipses. Ellipses are oval-shaped or egg-shaped pictures. They could be horizontally elongated, could be vertically elongated, depending on where the numbers are located, as you'll see in a minute here. But bottom line is, for today's section of notes, today's date, Monday, 4/13/20. The title is simply Ellipses. Very similar to what we did Thursday. We'll do 4 problems on the front, 1 in each block. A little more complicated problem on the back where we're going to algebraically manipulate a lot of stuff to get it into standard form. And you'll try 4 of these on your own for homework later tonight. It'll be due tomorrow on Tuesday at noon like we've been doing. I hope this routine is working out okay. Any questions or suggestions, certainly feel free to email me and let me know if there's any kind of issues with what we're doing and how we're attacking the learning process here. Okay? All right, today go to block number 1. Everybody write x squared over 4 plus y squared over 25 equals 1. Now, compare and contrast this with the circles that we did on Thursday. If you'll remember Thursday, it's been a while, we did have an x squared plus a y squared, and it always equaled some radius squared. Remember, x squared plus y squared equals r squared, and that was the standard equation of a perfect circle. And we had to know where the center was, where the radius was, to draw that circle accurately. Ellipses also are identified by having an x squared plus a y squared, but the big difference, of course, as you saw before I put my finger down, there's numbers underneath that x squared and underneath the y squared. An important note, an ellipse is only in standard form and can only be graphed accurately if it's equal to 1. Okay? So number 1 here, first of all, the 4 and the 25 at the bottom have nothing to do with the center of that ellipse. If I'm going to draw an oval shape, I still got to have a center point as a point of reference. Agreed? So just like with a circle, if it's good old x squared and good old y squared, and those x's and y's do not have like a -3 or a +2 attached to them, the center is going to be at the origin at 0, 0. So I know that this ellipse, which yes is in standard form, because there's a number under the x squared, a number under the y squared, and it's equal to 1. The center, of course, on this one is good old 0, 0. So when I go to draw my elliptical shape here, I am going to put a dot right on the origin and put CR for the center. Now watch how simple. It is not complicated at all. The x squared has a 4 under it. Agreed? Well, the x-axis, of course, runs left to right. Careful, you do not go right 4 and left 4. This 4 on the bottom came from taking some number and squaring it. Technically, the standard equation, if you looked in a book, is x squared over a squared plus y squared over b squared equals 1. So what number did you square to get 4? So we're still going to square root that number and, of course, get 2. So we're going to go right 2, left 2. The y squared, of course, the y-axis runs up and down vertically, correct? Has a 25 under it, and the square root of 25 is 5. So I'm going to go up 5 and down 5. And now when I connect my dots, it's not going to be a perfect circle. It's going to be an elliptical shape, an oval shape. Kind of looks like a football sitting on a tee. So we've got an ellipse. It's called a vertical ellipse because it's elongated vertically, where the major axis is running up and down along the y and the minor axis is running across the x. Okay? It really is that simple. Now slide to block 2. You see that equation there Guys, that is not in standard form, is it? You got to still think and be somewhat algebraically creative here when you manipulate and get it into standard form. It is only in standard form when it says x squared over a squared plus y squared over b squared equals 1. So guys, think about it. If this is supposed to equal 1 to be in standard form, then that 36 needs to turn into a 1. So guys, we're dividing both sides by 36. Obviously, on the right side, 36 over 36 successfully turns that into a 1. And as I cross cancel on the left, all I have is 4 over 36 and 9 also over 36. So reducing those, do you agree that'd be x squared over 9? Think with me, don't just copy. Plus y squared over what? 4, because 9 over 36 reduces to 1 over 4, equals 1. So simply dividing both sides by 36 allowed me to get that ellipse into standard form. I'm going to draw my picture. Since it's good old x squared and y squared, again, the center is at 0, 0. The x squared has a 9 under it, so I'm going to go right 3 and left 3 from the center. And since the y squared has a 4 under it, I'm going to go up 2 and down 2. So this guy is elongated horizontally from left to right. It's a football laying on its side. And that's called a horizontal ellipse because the major axis is running left to right. The minor, smaller axis is running up and down. Okay? Go to block 3. X plus 3 squared over 12 plus y minus 1 squared over 18 equals 1. Notice there's an x squared over a number plus a y squared over top of a number, and it's equal to 1. So algebraically, that thing's good to go. It is in standard form. The center this time, of course, is not 0, 0, is it? Just like circles on Thursday, the center will be the opposite of the numbers you see inside the parentheses. So the opposite of plus 3 is what? Minus 3. The opposite of minus 1 is plus 1. So the center is negative 3, comma 1. Some of you did that backwards, forgot to make the signs opposite when you graphed your circle centers the other day. I'm going to go ahead and draw my picture. Since the center is negative 3, 1, I'm going to go left 3, up 1, put a little CR so I can find your center immediately. Now, guys, careful. These are not perfect squares, of course, on the bottoms of the fractions. The square root of 12 is what? 3.5, I believe. So since the x squared has a 12 under it, I'm going to go right 3.5, and I'm going to go left 1, 2, 3.5. The square root of 18 is 4.2, if you did that on your calculator. So the y has a 4.2 for its bottom value. So I'm actually going to go up 1, 2, 3, 4.2, and down 1, 2, 3, 4.2. And now draw my ellipse. Since the bigger number is under the y squared, it's elongated up and down, and we got a big vertical ellipse, elongated up and down, situated on the left of the y-axis, okay? And our last nice normal picture, look at this one. The second you see an x squared plus a y squared, you're thinking it's either a circle or an ellipse, correct? This coefficient in front of the parentheses is understood to be a 1. If these coefficients are different, as in this case, it's an ellipse. Remember back to Thursday, if the coefficients were exactly the same, it was actually a circle. So bottom line is, as soon as I conclude this is an ellipse, I'm going to divide by 20. That way I end up with what? A 1 on the right side up, because again, any ellipse you're going to draw has to be equal to 1. This is 5 over 20, and this is a 1 over a 20. If I reduce, I'm going to get x squared over 4 plus y minus 2 squared over, still a 20, equals 1. There's my equation in what? Standard form. When I go to graph this ellipse, okay, careful. When I say to you, hey, where's the center? Obviously, that's just plain old x squared. So the x-coordinate of the center is 0. It says y minus 2. The opposite of that is positive 2. So the center is at 0, 2, right there. Since the x squared has a 4 under it, I'm going to go from the center, right 2, and left 2. The y squared has a 20 under it. The square root of 20 is actually 4.5, so I'm going to go down 4.5 and up 4.5. And when I draw my ellipse, it's elongated up and down because the bigger number was under the y. Obviously, if you take an elliptical shape and rotate it or spin it around its axis of symmetry, you're going to create an egg, right? A three-dimensional egg shape. And next year in calculus, you'll be able to figure out the volume of that, not by using a geometry formula, because there is no such thing, but by using calculus techniques. So if you can't draw these accurately this year, you're not going to be able to solve fancier questions next year in calculus. Okay? All right, look to the back of your paper. I'm flipping this thing over. I've got a big star by this crazy equation. 9x squared plus 4y squared minus 54x plus 40y plus 37 equals 0. Okay, if you were taking an ACT test, because some of the ones towards the end of that test can involve conic sections, you at least see an x squared and a y squared, so you're thinking it's one of those darn conic sections. Agreed? Is it a circle or is it an ellipse? Well, since this coefficient is 9, this one is 4. Oh, if the coefficients are different, it's an ellipse. If they're the same, then it's a circle. So my goal is to take this algebraic mess, and now I'm going to try to do something to it to get it in the standard form. Pay attention and think with me here. You're not going to get this right on your homework if you're rushing through this and not doing paying attention to the details like I'm about to do. So stay with me. Obviously, we're going to group our families together like we did on Thursday. So I'm going to write 9x squared, and then who's part of his family, minus 54x. I'm going to leave a blank space. Then I'll group the y family together. So I'm going to go 4y squared plus 40y, leave a blank space. And since that 37 doesn't belong to either one of those families, he gets shoved out of the way. So if I subtract him over, of course, I've got negative 37. Do not complete the square and fill in the blank yet. Uh-oh, why not? You're not allowed to take the middle number, cut it in half, and square it, and complete the square when the x squared has a coefficient in front of it. So guys, we're actually looking at this first family, and do you agree we can factor out a 9? I'm going to pull out a 9 from that group. That's my GCF, leaving me with x squared minus 6x in a blank. And in this second family, I'm going to factor out a 4, leaving me with y squared plus 10y and a blank equals negative 37. Agreed? Now I'm going to ignore this 9 for just a second. Look inside that first parenthesis. I'll complete the square. What's the process? Cut the middle number in half and square that answer. If I take negative 6 and divide it by 2, I get negative 3. Negative 3 squared is plus 9. And whatever you do to one side, you do to the other. So you're thinking, I'm going to write a plus 9 on the right. Remember, that plus 9 I just wrote has a 9 in front of that parenthesis. So that 9 has an effect on everybody in there. So 9 times 9 is actually 81 that I added to the left side. So I'm going to put plus 81 on the right side. Whatever I do to one side, I do to the other. And in the second group, when I take 10 and divide by 2, I get 5. 5 squared is 25. Now, I just wrote plus 25, but it's got a 4 in front of it, correct? And that's dot connected. So 4 times 25, oh my gosh, is actually 100. So on the left side, I've got 9 parentheses. And then remember, you take this perfect square trinomial and make it a binomial squared. And what do you put in here? Whatever you got when you cut the middle number in half. So it's x minus 3 squared plus 4 times, what's this going to be? Y, when you cut positive 10 in half, plus 5 squared equals, well, over there I've got 181 minus 37, which is conveniently 144. How about that? Now we're starting to get somewhere, agreed? It's starting to look like an ellipse. Obviously, that wants to be a 1 over there, so I divide by 144. So I end up with the 1 that I was seeking. And on this side, if I cross-cancel 9 and 144, oh boy, I'm going to push my calculator buttons here. 144 divided by 9. This ends up being x minus 3 squared over 16 plus y plus 5 squared over, if I decide how many times does 4 go into 144, that would be 36. Oh my gosh, I did it. I got that ellipse into standard form, and I could then graph this if I had to. Guys, when you do the last problem on your homework, all your job is to get it into standard form like I just did by trying the process I just highlighted. If you need to watch that again, go back to the beginning of this problem and watch and listen again and make sure you get the details of those steps. Okay? All right, homework or assignment, whatever you want to call it. It's a little 4-question quiz. Today is, again, Monday the 13th. So this assignment is due tomorrow on Tuesday the 14th at 12. Please stick to that routine, guys. I've got 111 homeworks getting sent to me all the time, every day, and I can't have you do this at your convenience in terms of turning it in late and that kind of thing. We got to keep up. I'm asking you to watch a 20-minute video and do a 5-minute homework assignment just to keep up on a daily basis, okay? So your homework, 2x squared plus 8y squared equals 32. X minus 1 squared over 10 plus y plus 2 squared over 16 equals 1. 4 times x plus 1 squared plus y squared equals 16. And 9x squared plus 25y squared minus 36x minus 50y minus 164 equals 0. Hit pause if you have to. There's your 4 homework problems due tomorrow, okay? All right, guys, great job. We'll see you tomorrow where we're going to work on a conic section called hyperbolas rather than circles and ellipses.